Hello dear student, myself Prof. Sukhbiraj K. Today we learn third chapter, motion in a plane. In this chapter we can firstly discuss what is meant by motion. See here definition. Motion is a change in position of the object with respect to time. Yearly motion of objects are mainly divided into three categories. Firstly, we can discuss here motion along straight line, that is called as rectilinear motion. Second type, motion in a two dimension, that is motion in a plane. And the third category, motion in a three dimension, that is motion in a space. Then last lecture we can discuss different type of motion. Uh, Firstly, we can discuss here what is meant by translational motion. Definition here: motion of a particle from one point to the another point. Is called translational motion. Next point we can consider what is meant by rectilinear motion. Definition here: motion of a particle from one point to the another point follows path in a straight line. This motion is called as a rectilinear motion. Next type of a motion is vibrational motion. Vibrational motion means what? Definition here: definition: to and fro motion of a particle about its mean position is called as a vibrational motion. And next type of a motion is a circular motion. Simple definition of a circular motion: the motion of a particle along circumference of a circle is called circular motion. These different type of a motion. Then we consider what is meant by uniform and non-uniform motion. A body is said to have uniform motion if it's cover equal distance in equal interval of a time. A body is said to have uniform motion if it is cover equal distance in equal interval of a time. What is meant by non-uniform motion? A body is said to have non-uniform motion if cover in equal distance in equal interval of a time. This is a basic difference between uniform and non-uniform motions. Then some question asks, what is the difference between displacement and distance travel? Displacement is the shorter distance between the initial and final point of a movements, and a distance is the actual path followed by a body between the point in which it's moved. This is a basic difference between displacement and distance travels. Then we discuss next point here. Next point, what do you mean by distance and what do you mean by displacement? Firstly, we discuss what do you mean by displacement. Uh, Distance definition: how much ground an object has covered during motion is called as a distance. How much ground an object has covered during motion is called as distance. And what is my displacement? Displacement Displacement is the overall change of a position. What is the basic difference between distance and displacement? First point, distance is a total path length of a projectile in a given times, and displacement means what? Displacement is the shorter distance between 2 points. Distance is a scalar quantity and displacement is a vector quantity. Displacement always positive, but displacement may be negative or may be positive. This distance does not depend upon direction, but displacement, it is depend upon direction. This is a basic difference between distance and displacement. Then we discuss next concept, what is mean by acceleration. Acceleration means what? Definition: the rate of change of velocity with respect to time is called as a acceleration. Mathematically, we can calculate this term: acceleration is equal to velocity upon time. Units of acceleration: SI units meter per second square and CGS unit centimeter per second square. We can calculate dimension of this physical quantity. This become L raised to 1, M raised to 0, T raised to minus 1. Then we consider next term, what is meant by speed and velocity. Definition: the rate of change of displacement, the rate of change of displacement, the rate of change of distance is called as a speed. And what is meant by velocity? The rate of change of displacement is called as a velocity. Here speed does not depend upon direction, but velocity depend upon direction. Speed is a scalar quantity and velocity is a vector quantity. We can mathematically derive this physical quantity. Speed is equal to distance upon time, and velocity we can derive in mathematical form. Velocity is equal to displacement upon time. See here, best example of a speed always. See here, 2 meter per second, here 2 meter per second. Here we cannot consider direction of the objects, and when any objects travel displacement positive direction, we consider here displacement of this object, consider here positive, positive 2 meter per seconds, and here these objects consider negative distance, then displacement of these objects is minus 2 meter per seconds. Then we discuss very interesting concept or important concept in projectile motion. Firstly, we discuss here what is meant by projectile. See here definition. Definition: an object thrown in air in any direction making some angle with horizontal is called as a projectiles. An object thrown in air in any direction making some angle with horizontal is called as a projectile. Another, for example, of a projectiles. First example, bullet fired from a gun. This is the best example of a projectile. Second example, a football kick in ears. This is another example of a projectile. And third example, a stone thrown obliquely in air. This is another example of a projectile. Then we consider another concept, projection. What is meant by projection? See here definition. What is meant by projection? The point from which the body is projected in air is called as a point of projection. The point from which the body is projected in air is called as a point of a projection. Then we consider next definition, velocity of a projection. Definition: the velocity with which body is projected is called velocity of a projection. The velocity with which body is projected is called as velocity of a projection. Another definition, what is meant by angle of projection? Angle of projection definition: the angle made by the velocity of projection with the horizontal is called as a angle of projection. The angle made by the velocity of projection with the horizontal is called as a angle of projection. And last definition, uh, next definition here, trajectory. What is meant by trajectory? The path followed by the projectile in space is called as a trajectory. What is meant by projectile motion? Another definition. What is meant by projectile motion? Projectile motion is a form of a motion in which an object or a projectile is projectile through near earth surface and move along a curved path along under the action of gravity. This type of motion is called as a projectile motion. Then we see here another point, trajectory curve. See this diagram. uh, um, this graph shows height versus range here. In x-axis we given range, and y-axis we consider height here. We conclude from this graph, at an angle of projection is 45 degree, range of projection is maximum. See here, uh, this angle at an angle of projection is 45, range of projection is maximum. If the projectile is projected at angle less than 45, a range of projectiles and maximum height reaches will be less than that at angle of a projection theta is equal to 45 degree. See here these angles, and if it is projected at an angle greater than 45 degree, this 45 degree, it is projected at an angle greater than 45 degree, the horizontal range is small and minimum height reaches is greater than at angle. And last conclusion, if the angle of projection less than or greater than 45 degree, the horizontal range is decreases here. And last point, what is meant by time of flight? Definition: time taken by projectile to cover the entire trajectory is called time of flights. Time taken by the projectile to cover the entire trajectory is called time of flight. This time of flight is denoted by capital T. Then the formula of a time of flight is given here. Capital T is equal to twice u sin theta upon g. Here capital T is a time of flight, u be the velocity of a projectile, theta be the angle of projection, and small g is the acceleration due to gravity. Here in this formula we can calculate time of a flight of a projectiles. Then next concept is a horizontal range. What do you mean by horizontal range? Definition: the horizontal distance between the point of projection and the point on the same horizontal plane at which projectile return after moving along its trajectory is called horizontal range of a projectile. This horizontal range we can denote it capital R. The formula of a horizontal range is given here. Capital R is equal to u square into sine 2 theta upon g. Here capital R be the horizontal range, small u be the velocity of a projectile, and theta be the angle of projection. In this formula we can calculate horizontal range of a projectiles. And small g be the acceleration due to gravity shear. Special cases from this formula, capital horizontal range. Here when theta is equal to 0 degree, then horizontal range becomes capital here uh, capital R is equal to u square into sine 2 into theta, means theta becomes 0 here, u square sine 2 into 0 upon g, then 0 into this term this becomes 0, that is R is equal to 0. When when angle of projection theta is equal to 0, then horizontal range become 0 here. And second case, when theta is equal to 45 degree, then 45 degree, then horizontal range capital R is equal to u square into sine, here 2 into 45, this become 2 into 45 upon g, here u square sine 45 into 2, this become 90, hence u square sine 90 upon g, sine 90, this become 1, then R is equal to u square into 1 upon g, means R is equal to u square upon g, means hot horizontal range is maximum, that is R max is equal to u square upon g. Note here the maximum range of a projectile at a 45 degree, the maximum range of a projectile at 45 degree. Then third case, when theta is equal to 90 degree, then we can calculate horizontal range of a projectile. This become R is equal to u square sine into 2 into 90 upon g, this become 2 into 90, this become 180. Here horizontal range R is equal to u square into sine 180 upon g, sine 180, this become 0, u square into 0, u square into 0, this become 0 upon g, means what R is equal to 0, R is equal to 0. Hence the minimum range of a projectile at 0 degree and 90 degree. In this way we can calculate horizontal range of a projectile at different angles. In this way we can complete third chapter motion in a plane. Today we stop here. Thank you.